Hey guys, welcome back to the channel. We're going to be solving the third question from the sixth chapter of the Beer and Johnson textbook. And we have to use the method of joints in order to find the force in each member of this truss. And we have to state also if each member is in tension or compression. So as always, we're going to start with the unknowns that we have at point A and C. So if we look at A, we'll see that we have a pin, meaning we have both x and y components, so we can call them ay and ax. Let's call our x and y in here. And if we look at joint C, we'll see that we have a roller, which means it can move freely in y direction. So we don't consider any force in that direction, and we're just gonna have a simple x component. We can show it with C or CX. Really doesn't matter. But before we start, let's just find some of these dimensions that are missing in here. So if we look at this right triangle here, we'll see we have one side 3, this side is 1.25, and if we use the Pythagorean theorem, we can find the hypotenuse. But here, if you multiply everything by 4, so 3 times 4 is 12, and 1.25 times 4 is 5. And now it's that famous variations that we have for finding the hypotenuse. So 5, 12, this will be 13, or we can have the square root of 12 squared plus 5 squared, which is going to give us 13. So that's one of the dimensions that we need. Also, if we look at the other triangle, I'm going to show it with green. This right triangle, we have another combination. We know this one is 4, the base is 3, and the hypotenuse would be the square root of 4 squared plus 3 squared, which will be square root of 25, so this is 5. So now that we have these missing dimensions, or the hypotenuse of these two triangles, or I should say right triangles, we're good to go. We can start with our equilibrium equations. We are in equilibrium, so in order to find the unknowns, it makes sense to start with moment at point A, since we have the most unknowns at point A. So counterclockwise positive, and we are in equilibrium. Sum of all forces is equal to 0, and we have the same scenario for moment. So we have the moment of 84 kilonewton. As we can see, the moment is counterclockwise, so positive 84, and the distance that we have is the vertical distance from line of action to the point that we are trying to find the moment about. So from A to here is the distance that we are looking for, and keep in mind the distance is 3. We just multiply every distance, all the distances in here, by 4 to get to that famous combination, but the distance that we have in here is 3. And we also have the moment of C, which is clockwise moment, as we can see. So negative C times the distance would be what we have from here to here, which will be 4 plus 4, 1.25 again, not 5, 1.25, so it will be 5.25 is equal to 0 since we are in equilibrium. So C would be 84 times 3 divided by 525. So 84 times 3 divided by 5.25, that's going to give us 48 kilonewton. We didn't get any negative sign. That shows that the direction for C was correct. Now we can do our fx and fy. We can do sum of all forces in x direction. So we have ax and we have c is equal to 0. Ax will be 48 kilonewton. 2, again, no negative sign. That shows ax is to the right. And last one, we do the sum of all forces in y direction. We have ay minus 84 kilonewton is equal to 0, and our ay would be 84 kilonewton. No negative sign. That shows that all of our assumptions for the directions were correct. So now that we have this, we can move on to our joints, each of them, in order to find the force in each member and see if they are in tension or compression. So let's just start with the joint A. So at joint A, we have our AX and AY, which we found from the previous step. And we found that AY was 84 kilonewton and AX was 48 kilonewton. And we also have two more forces, which is the force in member AB and member AC. So we can show it with FAB, and here we can get an idea about the direction of the FAB and FAC. Obviously, FAB is the only one that has X component, so it has to be in this direction to cancel out our AX. And for FAC, we can consider it downward for now. And if we get a negative sign, that shows it's upward. So let's do sum of all forces in X direction for this joint. So we have AX minus FAB. And what we figured out for FAB was this was 5, 12, 13. So times 12 over 13 is going to give us the horizontal component is equal to 0. So FAB would be basically 13 divided by 12 times AX, 48 kilonewton. So we can cancel out 12 on 48, which will be 4. 4 times 13 is going to give us 52 kilonewton. So no negative sign. We kind of knew that the direction for FAB is correct. And if we want to find the members in tension or compression, so the member is somewhere in here, and based on Newton's law, we have to have a force in the opposite direction. So as we can see, the member will be in tension, so we have a tension force in here. And we can do the sum of all forces in y direction. And for y, we have AY, which is 84 minus FAB, which is 52 times. This time we'll have the vertical component, which will be 5 over 13 minus FAC is equal to 0. So here FAC will be basically equal to 84 minus, you can cancel these two, 4 times 5, 20. And this is going to give us 64 kilonewton. And again, no negative sign for FAC. That shows that FAC was actually in the correct direction. Again, the force that is applying from the joint to the member has to be in the opposite direction of what we have in there. So tension, this force is also in tension too. This member is also in tension too. So we found FAB, FAC. There's only one left. We can move on to another joint. So if we go to the joint C in here, we can find the last unknown, which is FBC. So we're going to find the joint C. What we found at C was the force C in here, which we figured is 48 kilonewton. We have the FAC and FBC. Obviously, FAC has to be in this direction based on what we found in the previous step, since the member is in tension. So this is the force that is applied from member to the joint. So the force in the joint has to be upward or in the opposite direction of the force applying from joint to member. And there's one more force, which is FBC. And looking at this, we'll see that FBC is the force that has X component. So if it is in this direction, it will cancel out the X component or the force C that we have in here, which is the only force that has X component. So that should be the correct direction for this. And we also figure out that here we have 4, 3, 5. So we have the same thing in here. This will be 4, 3, 5. And let's start with the Fx. So we have FBC, the X component would be 3 over 5 minus 48 is equal to 0. That's the only force that we have. So our FBC in here would be basically 48 times 5 divided by 3. And cancel out 3 and 48. It will be 1. 16 times 5, which will be 80 kilonewton. And let's just figure out if the member is in tension or compression. So the member would be something like this in here. So we have to have the force in the opposite direction. So this time the force the member is in compression. So that would be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. We're covering different textbooks in this channel. Feel free to check out the playlist and let me know if you have any specific problem in your mind and we can cover it in the next videos. You guys take care. I'll see you in the next one.